Hi, this is Rashmi. I have Michelle here, and we are welcoming you to the BPS Summer Coding Sampler, Session 10. So today we'll be working with Python and JavaScript. Let me quickly switch to today's agenda. Okay. So today's meet is at Coding Sampler Session 10. We are live, so please do announce yourself as you enter the today's meet session, and welcome again to the Session 10. So today we are going to work with a lot of different programs and interesting programming languages such as Python and JavaScript. So without further ado, these are some of the programs that we will be working with, which allows us to work with a little bit of variables, how to declare, how to print, and then we have some more challenges. I also wanted us to sort of go through exporting a function or a program into Python and then being able to use the graphing capabilities of Python so that we can see some creative, creative programs such as this, turtle drawings, which also work with variables really well. And then we will go into changing some of the parameters of the squares and the circles that we're drawing to making it into a more iterative sort of process. And this will allow us to, sort of work with the Python syntax, but at the same time, enjoy ourselves while we do some of these programs. There is a Go Beyond challenge that I'll explain, and I'll show you what it looks like. Hopefully, you will undertake this. This is obviously not required for you, but as we go through some of these details, you'll be able to see how this will eventually evolve from the square and the circle, and then making multiple spirals. Last but not the least, we are also going to try to look at a program which starts with sort of a program statement or a problem statement, and then we'll go into devising our plan for, in this case, ordering a pizza, and then programming that within the context of Python. So logistically, again, we are in session 10. So this is your session 10 coding sampler. Which is the today's meet link. So please do join us. If you're joining us live, you can always watch this webinar via video, and then you can do the assignments as well. So I just wanted to quickly take you to our course, which is, this is how it looks like. I'm hoping that we can get to the JavaScript and the programming of JavaScript, because these two languages are really very, they're friendly, but at the same time, we're going to go through some of the examples which might take time. So depending on our time, whatever is remaining, we will fold that into the next webinar series that we are planning, which will inculcate a lot of programming assignments from Python and JavaScript as well. So in this BPS Learns, you'll be able to see the webinar. You'll see the Mad Lib challenge homework. The exit ticket is linked here. The challenge for homework is linked here. And then the third homework challenge is also in here, and the resources. I will also update the some more assignments or resources as we complete this webinar, depending on how far we get. So that's sort of our quick logistics. Definitely, we are quoting all our resources, so do that if you are working with some images or media files from any other resource. Please make sure you quote that resource. So delving into Python. So why get into Python, or why learn about JavaScript? So I quickly wanted to take you to the, there was a really great survey done by Glassdoor, which talks about, the 9 most in-demand programming languages in 2016. And as you can see through this graphic, JavaScript and Python feature right in here. And they are very essential languages, partly because, as you can see, Python is a general purpose programming language. And funnily so, if you enjoy British comedy, Monty Python's Flying Circus was one of the really great shows that I used to watch as well. And the creator of Python is actually a big fan of that program, and so he or that serial, and he used Python from there and named this programming language as Python. So as you can see, it has a really fun original beginning, as opposed to the Python that features on every Python cover. So it's not really the Python behind which the language is named, but it's the Monty Python's circus. So Python is simple. It is incredibly readable and closely resembles the English language. That's why it is very helpful when you sort of go through Python's process, because it really helps you in terms of high code readability. You can express concepts with few lines and codes. It supports most programming paradigms, which essentially means that when you go through Python code can be packaged as an executable program, standalone executable program, and so it can be run across many popular operating systems. So CPython is also a reference implementation of Python, and there it includes many of these object-oriented or functional programming or procedural programming paradigms. So that is a really great way why Python is so widely accepted. We also want to show you this quick graphic, wherein, right here, this is where we fall in terms of the software development process. So you have an idea, you sort of go to a text editor and you program the idea, which is essentially your program. You compile it, which is what's a compiler? It takes a source code, which is what we give them, converts it into machine language and feeds it to the machine, and then the machine is able to give you an output. And then you go through these stages. The program goes through the assembler, linker, debugger, program stage, and then you see what works or not. And if it works, then you are great. You can document the program and use it and sort of move on to the next project or next part of the programming. If not, then you sort of go back into the feedback loop and either go to the ideation stage or go back to the text editor to see if what changes you need to do. That's a very very rudimentary sort of structure of a software development cycle. Obviously, there are many different steps added to that. We just wanted to give you a quick survey of, we've looked at block programming languages, introduction to Scratch or Scratch Junior. We've looked at Hopscotch. We've looked at, Logo, or many different block programming languages, which are essentially great in developing concepts for kids. And then from block, you move into text-based languages, which is essentially what Python and JavaScript are. The difference in this, as you can see, all the text-based languages, which are these nice circles that you can see on the right-hand side, are the languages that also feature in this breakdown list for programming jobs. So essentially, these are the languages or the professional languages for which you are hired for. So if you can see, Python does have a big chunk of percentage in terms of wanting to learn Python because it features in many different applications. But at the same time, Python is also highly recommended for middle school, high school programming curriculums because of its simplicity of implementation. We do want to emphasize that Python is being adapted into the APCSP, which is the AP Computer Science Principles program. So the syllabus has adopted Python in one of the implementations for these APCSP principles. So that's why adapting a language that's simple to use but also has this wide variety of implementations is very important. This is again another data, RedMonk is a really great um, sort of aggregate of different types of languages and programming, you know, skills that you need in order to be, in order to have a really great resume to go out there and get these wonderful jobs. So that's a great resource. You can take a look at this sort of a breakdown of the programming languages and what are sort of Rasmussen also publishes this every year. I got the 2014 version, but you can see the 2016 version. I believe it will be published very soon. And we talked about Python a little bit and why Python. So sort of let's start getting into how you can get Python. So there are a number of options. What I wanted to show you was you can go to Python, which is the Python software, the original python.org, and you can download the latest version for Python, which is the Mac OS X version. And I highly recommend downloading the Python 3.5 because it really works with your Mac version. And then I know you won't be able to do this right away, but as you go through different versions, maybe you can try the 3.5.2. I have 3.4.5 on my version on my computer, and it works fine. And I'm working through an L4L, so this should be great. You can also look at these beginners guide, and I have I'll be posting links to these into the resources section. So what this allows you to do is, gives you a lot more information about how you can install. For non-programmers, there are some suitable tutorials, and this is a great place to start. There is some online documentation and some simple tutorials about what Python looks like, and then some editors, and there is this really nice beginner guide pages that you can go step by step. You can look at some exemplars or downloads. So this is a good sort of section that you can look at, and this is a great resource for learning a little bit more about Python. Or you can always post questions to the FAQs, which is the news group, and they are very responsive in terms of responding to the to your Python queries. So the other place you could do Python is Code Academy, and this is what I did is I went into Code Academy and I literally opened up the Break It Down, which is I believe Pig Latin is their third challenge, and I just opened it up, and what it gives me is a Python console, and it also gives me a compiler. This does have a tendency to break down on you a little bit, so I recommend you downloading Python and having it on your machine, on your computer. And let me quickly show you what that looks like. So I'm going to have I'm going to write a quick program. So let's say we want to write let's say we'll write hello everyone. So you just do a simple print command. You say welcome to Python, and then you close it, you run it, you save and submit, and it really just prints what you've asked it to print. But this is a nice way of sort of looking at your simple text commands in Python, and you can run it. The total program that I'm going to show you in a while does not run on this in this interface because it cannot import the graphics needed for that. So you have to run it through the native onto your machine. So let's quickly look at, I wanted to show you the versions. So let me open up a program that you might like. So I'm going to show you one fun program, which is essentially your Explore challenge. So This is just to see. We are not going to do this immediately, but let me switch my screen to that. Okay. So when you, it is sort of hard for me to show you both sides of the screen. So this is where I've written the rubber band ball program, and this is essentially a text editor, hence the text language, which allows you to write the program for Python. And it's a very basic text editor wherein you import. I'm going to draw using a total program. So I have total, and then it uses many different dot pen, BG color, and we'll talk about the specifics of this program. The key is when you run a Python program, you have an option of run module in the run option up there, and you can say source must be saved, of course. And when you run a program, it will show up like this. And I want to show you what that looks like. So let me quickly switch to the, this is the harder part of showing Python programming from your machine to the, oh, let me zoom in. So on using Google Hangout. But what this allows you is a more stable interface for you to program, and it really does not crash on you. I've tested close to hundreds of programs on this shell, and it does not crash on you. While as the online ones, they do tend to crash and will not do the graphic aspect of it. So this is our very basic program. I'm going to stop that. I'm going to come back to our discussion. While my program keeps running. So we're right in here. Okay. So let's take a look at what does it entail in terms of installing Python on your computer. So you are going to download Python from here, and I recommend getting the latest version. Then you are going to go into your download folder, and ideally as is the environment that we'll be running it in. You have a command window, which is what you saw, where you write your program. All Python programs have a .py extension, so that's why they are Python programs. And it's very simple to run these programs. You just go to the run menu and just say run module, and the shell will show you the result. So that's essentially what's happening even in an online compiler. But what this online compiler will allow you to run basic text-based programs, but will not do a lot of importing of like a total graphic program, because it gives you an error when you try to do that. So that's sort of your installation. That's your window, which is what I showed you in terms of, that's your Python shell, where you actually see what the output looks like. So it's a basic text box where you can see the output. Very similar to what we saw in here. It's a basic text box where you see the output, and a basic text box where you can write the input. And then you have the build. This is what your package looks like. When you double click that, you get the complete Python package. Running and saving the program, we talked about it in the menu. You have run, you run module, and then you save your program, which is a .py file. So we're not going to do print hello world, but let's go back to our simple Python shell, and let's start with, say, let's print a joke. So green grape, blue grape joke. So whenever I put that hashtag in the front, that's my comment. So I'm going to write print. It's a simple command. and I'm going to write, what did the green grape say to the blue grape? Okay. It's important to have these um, quotations at the end when you're printing, and what this gives me when I click on this, it tells me that my brackets are closed. So this is a nice little print command that I know will work. But if if I take this out and if I try to run this code, it's going to give me an error, because I have an invalid syntax and it's showing me where the invalid syntax is. That may not be the case every single time, that the error will tell you exactly what the problem is. But in cases of simple commands like print, or sometimes even a loop command like if or for, it will. So reading those are really helpful, but also sort of making sure that as you're writing your code, you are keeping track of your curly, not curly braces in this case, the normal braces, and also the quotation marks. So what did the green grape say to the blue grape? And I want to print an answer. And this is something that my niece told me, so I'm going to just use her joke. Read. Yep. So I'm going to stop that. I'm going to save and submit the code. So what it's saying is line 3 module, it's giving me error. I want to know what the error is. As you can see, my print command here is different from my print command here. And the reason is that I have a capital P at the beginning, which is important to note because it is case sensitive. And when I changed it to lowercase p, it took the command, and now I do not have any of the errors. However, in this case, it did give me the print, the name error print is not defined, and that's a really good error to have because it pinpoints you to where a possible problem could be. So now I have corrected, and it gives me, what did the green grape say to the blue grape? Breathe, breathe. Did you get it? So that's how you start printing in Python. So let's look at another program. Now we are going to we're printing directly to the screen. So what I want to do is I want to save it in a variable. So let's introduce, I'm going to try to get interactivity with the console, and Rashmi's name program, and I'm going to save it as O1. That's my that's my comment. So it really doesn't matter if I am looking at the that's not going to compile. So I'm going to write name, that's my variable. And as you can see, it's really easy to define a variable in here. And I'm going to say input. So that's the input you're going to give me, or I'm going to insert in my console. So I'm going to say, what is your name? And I'm going to put in this tag. I did forget something. I did forget to close my tick marks, and then I am going to take that variable and I'm going to print. I'm going to say hello, or H capital. Whatever you print is what's going to show up. And then I'm going to hello. And I'm going to say name. That gives me, so essentially what I'm trying to do is I'm going to ask a question, what is your name? And when I enter that name, it's going to print that hello in the front and then the name. That's what it's going to do. Let's see if it if it's going to do that. So it asked me a question, which means it's seeking my input. And I'm going to give it that. And there was a problem in here because I have a bigger string name and I have space in between. So let's say I'm going to save and submit code. And if I just do Rashmi, it's going to still take, it's going to give me, it's still going to give me an error. So let's see what the error is. Okay. Now let's see, save and submit code. Okay, file name string line 1 and module is not defined. So it's going to give me a very simple problem of not identifying the name variable. So what I'm going to do is, give me a quick second. I'm going to try to just go in and change my name to, sorry. I just changed the spacing right in here. It took my name correctly, and I'm going to save it. And I'm going to say, yep, it did not take my name. So, so this is one of the reasons why you may not see the same problems being executed in this compiler. But if I change it, and if I take you to the compiler, which is the native compiler, and if you see, the program is the same. We do not have any difference in the program. So what it's going to do when I compile this program, it's going to give me, and I'm going to take you there. So give me a quick second. I'm going to take you to the compiler. Yep. Okay. So if you can see, it asked me the question, what is your name? It asked me that question. When I ran the program, it asked me, what is your name? And it keeps on asking me that question. So I say, so then it gives me, hi, what is your name? And it keeps on repeating what is your name into the into my loop, but it prints that loop. While as in this case, quick second, to go back to this. Okay, so let's write another program in here. And we are going to try to put in jokes with strings. So let's announce Fred, who is, so I'm going to put them in code. What is pink and fluffy, right? So that's a question. And the answer is pink, fluff. And when I say that, and then my second part is going to be print Fred. So when I print Fred, it should give me it should give me the question, what is pink and fluffy? And it should give me the answer pink and fluffy because they are all in the same variable. They're stored in the same variable. So I'm going to save and submit the code, and then it printed exactly what I wanted it to print. The none is after that, there is nothing. That's what the none indicates. So that's my first program, and you can go on with that. But I could also program it this way. So in variable Fred, I'm going to store why do gorillas have big nostrils? And I'm going to say big. Either I can, so that's my question, right? So that's my question. And I'm going to create another variable, which is answer. And my answer is, because it's big fingers. Because they have big fingers, right? So that's, my question is this, my answer is this, and I'm going to print, I'm going to print my question, which is question, and then I'm going to print my answer. And notice that I am trying to maintain the capital letter and small letter. Usually in computer science, it's a good habit to always stick with lowercase unless if you are following a naming convention, which is like the camel case. So in that case, you try to go low and high in terms of your naming convention. Okay, so we've saved this, and I'm going to save and submit the code. And it really, essentially, it took the questions, it took this string, saved it in the variable question. The answer variable had because they have big fingers. I printed question, I printed answer, and that's my sequence, as you can see in the output. So that's a basic way of using variables to take in string input. Now I'm going to do, let's go back to one of the challenges. So we kind of looked at that. We have a Mad Lib challenge, which is we'll ask the user for an adjective, a noun, and a past tense verb, and store them in 3 different variables and then we'll print out a sentence like the adjective, noun, verb over fun orange buddy. So orange buddy is the dinosaur orange buddy. So I just made it up in terms of our combinations of adjectives, nouns, and verbs will be forming this sentence. So let's get to the challenge. So let me go back to our Python. Okay. So this is our Rashmi Mad Lib challenge 1. Okay. So if you see, when I talked about camel case, this is what I mean, that I have a hump in terms of the R, which is a capital R. Then I have my it changed from mad and lib. So M is capital, then I go lowercase and lib. So it helps readability of your programming challenge. So in this case, this is just a way of declaring what my program is. So I'm not, but that could be my name as I save the program file. Okay, so fun orange buddy. So let's say we need an adjective, right? So that's our variable. And we want to give it an input. So we want to input the adjective. And we are going to ask the user to please enter an adjective, right? So that's how I'm taking the input. Then we want a noun. So I'm going to declare my variable noun. Then I'm going to say input. I could place it this way. And then I'm going to say, please enter a noun. A fun noun. How about that? A noun. And then we are going to close bracket. Then we also, what else did we need? We needed a verb right in here. So, and we also want a past tense verb, right? So we are going to go back and we are going to say verb and input. Please enter a past tense verb. Or we could very easily say a verb ending in ed. So we could say enter a verb ending in ed. So we got that. Now what do we need? We need to print the Mad Lib, correct? So our Mad Lib is going to be print, let's say, Rashmi's Mad Lib, because I am writing it. And I'm going to do that. So it's going to print that. And then I'm going to say print. That's where my sentence structure will be. So I'm going to say the, or capital the, adjective, that's my string, then I comma, then I say adjective, which is my variable adjective, noun, which is my noun, verb, over, what is it, over fun, what did I say, fun orange buddy. Okay, so I'm going to go in fun orange. So we got that, and then I'm going to close that. So what this gives me is a structure for how I want to print. So I took an adjective as an input, noun as an input, verb as an input. Then I'm going to print the sentence structure that I'm asking you to do in this challenge, correct? So let's go and compile and see if we have any errors. Ooh, we don't. Okay, so what's a good adjective? Let's say brave. Okay. Okay, so this is one of the problems that it will, this particular error has, because it doesn't go through all the challenges. So it's, please enter an adjective. It will keep on giving errors in terms of for this particular online. So I can probably try to refresh it and see if it would work, but it may not. So what I'm going to do is again move back to our to the native Python code, and I'm going to print in there so that okay. So what I got is the Python compiler. It's what you're seeing at your end. So I'm going to retype this hashtag madlib.py hashtag okay. I'm just going to copy it from there, and I'm going to paste it here so that I don't have to retype it. So I got that, and it's the same program that we have over fun orange buddy, and we are going to run it. We're going to run it. So I go to run module, and when it says run, it's going to give me, let's go back to that interface, and you'll see at the bottom it asked me, that's where the program is compiling. It asked me, please enter an adjective. So I'm going to say brave, right? and then it's going to go in. It's asking me, please enter a noun. So I'm going to say brave mouse, right? Brave mouse, and I want past tense, right? So slept. And then it should combine all of these adjectives, nouns, and verbs into the Mad Lib, which is the brave mouse slept over fun orange buddy, which is exactly what we were hoping for in terms of our challenge. So as you can see, there are many different challenges that you might face in terms of compiling the Python code online, as well as the most reliable way of compiling code in Python is, of course, have it in your have a native download of Python and then run through the shells. That will really help. So that's our first challenge. The second one, this is what we wrote. So I just wanted to quickly go through it. We took the adjective input, took the noun input, and then we are going to the verb input. We printed the Mad Lib, and then we printed the the final Mad Lib, which is the adjective, noun, verb over fun orange buddy. So we concatenated the string. That's a really great term to use to get to our final sentence. Now, what I want you to do for the homework challenge is add another input line that asks for a type of animal. So in this case, we said, we talked about, fun orange buddy. That's a definite, it's like a string that's in there. But what I want for homework is you can even make that as an input. And then you change the print statement by adding a new animal variable after the end of the quoted sentence. Add a comma before your new variable inside the print statement. So you could wind up with like a statement like the funny chalkboard burped over the lazy brown gecko. So instead of fun buddy, you can have a lazy brown gecko, things like that. So that's your homework challenge, modifying this existing program to change the language. And this should be, it cannot be, you cannot change just the over fun orange buddy to, lazy brown gecko. The gecko part of it, buddy in this case is the dinosaur, but the buddy part should be a variable. So if I want to add gecko, I should be able to add gecko. If I want to add elephant, I should be able to add an elephant or a lion or a tiger. So it's dependent on the user input, and that's what I want. I want this string or this constant to be changed into a variable in your program. So that's your challenge number 1, which is your assignment 2 in your homework, which is right here. So that's what you'll be doing for your assignment. Then let's go to the next one, which is the total challenge. And I want, we cannot do this in the Python builder. And I know we are sort of approaching a really quick deadline of our programming webinar today. So what I'm going to do is not go into the details of JavaScript and bring that into one of the next sessions in the webinars, maybe not this series, but an entire series on Python and JavaScript. But let's go to the total challenge so that I can show you how you can compile a total program. So I'm going to take you to, give me a quick second so I can go to the, I'm going to open up a Python program, which is a basic square, okay? And then I'm going to take you there so that you can see the program. Okay. And all you're seeing is I have, I'm going to take a square, I'm going to spiral it, so iterate it. That's what I'm going to try to do. And you see that I'm importing turtle, which is I'm importing Turtle, which is the program, and then I have a pen tool in the Turtle program, and it allows me to, for X range from 1 to 100, I go forward, then I turn by 90 degrees, and then I'll keep on doing it until the value of X reaches 100. So that's a very basic program, and I'm going to compile it. So I'm going to run the module, and what it does is it will start the Turtle module, and let me take you there so that you can see it. And this is what you should be able to see. It keeps on continuously drawing the square, and that's the Turtle graphics program that we've imported, which will allow you to see the the turtle. And now it's start because we have an end value of 100. So let's go back to a next program. So I'm going to switch. Okay. Okay. So you can see the program right in here. And what I'm going to do is write a program where I can probably tilt the turtle. So what that's going to do is, instead of this 90, which is exactly 90 degrees and it's moving and it's turning at 90 degrees, I'm going to make it 91, which should give it a little bit of a tilt in terms of formation of that turtle. So let's save this, and then I'm going to run this program. So I'm running the program, and let's go back and see how that looks. Okay. So what you're seeing right now is that just a 1 degree, 91 degree turn as opposed to 90 degree is giving you that nice little tilt in your square program. And you can see it's iteratively doing it until you reach the value 100. So it's looping. Now we are going to add some color to this program. So let's go back to our unfortunately, we cannot do any of these in the we cannot do any of this programming in the online version because we cannot import the Turtle graphic in there. So now we changed it by 90 degrees, 91 degrees, and now we have the we're going to open up. Give me one quick second. We're going to try to add, just vary this program to add. So we have our Turtle pen. We imported our Turtle. We have our Turtle pen, so it's going to draw. I want the Turtle pen to change to turtle.pen color to red. Okay. So that way, I'm hoping that instead of the black drawing that I'm getting of the square, I will get this. So I'm going to save it, and I'm going to run it. So as this runs, I'm going to show you what it looks like. Okay. So what you're seeing is essentially the Turtle graphics program with the red color. And while we are doing that, I'm also going to add I'm going to change, and instead of just one color, now I'm going to add more colors. So that's what I just did while I'm changing the program. So let me see. Okay. So what I did in this code, as you can see, I imported the total program, and I am adding red, yellow, blue, and green because I have 4 sides. I'm adding 4 colors to the to that square for the range of 100. So it will keep on repeating. T dot pen color. 4, then it goes forward X, then it tilts by 91, and then it will do so with a different color, which is the yellow, then it'll do blue, and then green. So you'll see how that looks in the program. So let me run it, and it should, okay, it came up, and I'm going to share that screen with you. The hardest part of this is to be sharing screens all the time. I wish we could do an online compiler with this. But as you can see, there is a consistency in colors that is being showcased in here. And one of the homeworks that I need from you is going to focus on spirals and circles. So in this case, we move from a basic black and white iterative square to changing the angle of that iteration, to then changing the colors of that iteration. And now we are going to go in and change the background of this. So everywhere we are seeing that there is a white background. So I'm going to go back to the program, which is the BG this one. So now what we have in here is we have the turtle.pen, but the background by default is always white. So we are going to change the background to, so BG color, which is the background color, to black. And I could change it to yellow, green, whichever color, but I'm choosing black so that I can see all the vibrant colors. And I'm going to keep this, I'm going to increase a little bit just to get a little denser feel to my square, just to make it a little bit more exciting. I am happy with this program. I'm going to save it, and I'm going to run it. So let's run it, and I'll show you what it looks like. Okay. So what you're seeing is, again, a repetitive pattern. This time you'll see a little bit more, but with the black background, and it's again tilted at 91, and you're seeing more iterations. So we defined it as 200 in our for loop. So you can see that much more in here. So I wanted to show you what this would look like in terms of a circle spiral. So let's see. Okay. Now that is over, so I'm going to stop that simulation, move you back to the program, which is our, okay. And what you're seeing in here is, sorry, okay. I'm going, okay, I found it. I'm sorry, it takes me a little bit of time to find the program on my computer. Okay, so this is where we were. We have the background color black, then we have 4 colors to our sides, and then we are going to go to the, what we want to change in this case is a circle. So in this case, we are just moving forward by X amount, and X being defined in our for range. Now instead of forward, we are going to move it as a circle. And then we're going to keep all the parameters the same with multiple black and the background being black as well. So that should, I'm going to save it, I'm going to run it, and this is what we see. So So you're seeing multiple squares iteratively being drawn into your, yeah. So, and if you want to change that to, so it'll keep on drawing until I have 200. If I can increase the, I can increase it to 300 in the for loop, and it will keep on drawing. So that's really great. But what I'm going to show you now is, let's go back to this. And in here, we kind of looked at the first turtle challenge, which was, we went from the black and white square iteration to, tilting the angle, changing the color to one color, to multiple colors, to color and background, and then, changing around the iteration as well. Now we also looked at, a similar sort of logic is applicable to one variable spirals, which is, we are doing the circle. Then you can change it by an angle, and then you can further change it with the black background. Now the homework for you is, but before we look at that homework challenge, I wanted to show you the program that will be running. So give me one quick second. I'm going to run this. So, okay. So what this does, this is the program. So you can see the program first. Okay. Okay. So this is the program where you have, you can change the sides. So I'm naming the sides 10, and I have 10 colors in here, and it's pretty much the same as I'm doing with my squares. So if you look at the output, this is what the output looks like. Yep. And it's still drawing. So it'll keep on drawing until, because we have 10 sides in here. And that's the version. So you have this program, and it'll keep on drawing until you obviously stop it or shut the program down. And what happens in this case is, what I want from you in terms of the homework challenge, yeah, you can see this. So in terms of the homework challenge, I want you to seek users' input in terms of the number of sides while the program runs, which means I can tell you whether it's 2, 6, 8, or 10 sides. So the diagram could look accordingly. Ask the user for a number of sides and store that input in a variable sides, just as we did with our jokes program. Our only extra step is to evaluate the number the user enters. We can find out which number the user typed with the eval function, like the sides equals eval, and then the input, enter the number of sides between 2 and 6. So it's sort of, you want to check whether it's correct. Your input, if I enter, say, number 20, it should be an invalid input. So that's sort of your homework challenge. And I wanted to show you this version, but we are way out of time. So I'm going to attach one of these programs to the into the classroom so that you can see it. I did want to show you what your challenge is going to look like. And this is the program that you will have accessible to you in your homework. So I'm going to quickly show you. I cannot compile that here, but you should be able to see this program. So this is the hex color spiral program where you can choose between 2 and 6 sides. So you have the basics of the program. In this case, the sides is 6, but I want you as a user to be able to give this input, and that's what you're changing in your homework challenge. So, and that's your Go Beyond challenge, which you can obviously look at, which is trying to change the multicolor.spiral.py program into a more tangled and abstract shape just by adding an extra turn inside and ending the drawing. So this is not a required one. You can always look at it and change it. I'm going to post some of the code in the classroom, and you can play with it. I also wanted us to take over this challenge where write a small program to figure out the total cost of a simple pizza. We may not have time today to do this, but I sort of wanted to at least get to the stage where we look at it as a plan. Sort of all of this input, which is the challenge, the key algorithms for defining this order your pizza algorithm is ask people how many pizzas they want. That's the first question we are asking. We are asking for input for the menu cost of each pizza. We are calculating the total cost of pizzas as our subtotal. Then we are calculating the sales tax owed at 8% of the subtotal. So this is something we're doing. The calculations we're doing internally, asking is the input from the user. And then we are again adding the sales tax to the subtotal of the final total. And then we are showing user the amount due, including the tax. So that's sort of our algorithm when we go from here, which is just the challenge, to going to a plan, an algorithm where we now know what are going to be our inputs, what do we do with our inputs, how do we calculate it, what do we, in this case, it's going to be an addition, and then what are we showing, which is our print statement, what are we showing as an output to our operator. So that's going to be a programming assignment that we'll undertake in our Python webinar series. I did want to go over JavaScript quickly because you can run JavaScript in Google Chrome, and you just have to install Chrome on your computer. If it's not already installed, that's the link. And then open and type blank in the address bar, and you should be able to see and execute your code and also display the result in the next line. So that's how you can run JavaScript. Or you can always go to the Code Academy JavaScript place where you can input your JavaScript code just like your Python code, and you should be able to run your JavaScript in here. I wanted to quickly sort of get into this programming of JavaScript, starting with just a basic, drawing a simple cat using the text editors. So I'll post this program if you have time, try it out. And this was going to be our challenge where we get to program rock, paper, scissors, and then enhance it to the rock, lizard, paper, spark, scissors challenge, which is, if you are a big Big Bang Theory fan, you know what I'm talking about, but this is a more convoluted programming challenge when it comes to rock, paper, scissors. So that was going to be the programming challenge that we were going to undertake today. However, we don't have as much time. I'm going to try to see if I can launch another webinar series with multiple programming challenges that include Python and JavaScript, and I will keep you updated with that. This is how the code compiles. This is something that I had done for the rock, paper, scissors challenge. So it literally asks me prevent this page from creating additional dialogue. That's fine. But it asks me, do you choose rock, paper, or scissors? And I'm going to choose rock. And the computer also had a rock, so there was a draw. Then I can run it again, and this time I'm going to again choose rock, and computer had a rock again. That's not fair. Okay, I'm going to scissors. Yep, and then this needs to be updated, the code. Okay, so now it will do the reset, and I'm going to say paper, and computer had a rock, so I guess there is a change. The point being, we are going to take a program, program it for rock, paper, scissors, and then go on to advanced programming with rock, paper, scissors, lizard, spark challenge. So again, going back to our pathway, it is very important to stick to standards. There are CSTA standards, which are K-12 computer science standards. There are MADLCS standards, which are the strands, and they're derivatives of the CSTA standards. And you can see there are 5 strands in CSTA, while there are 4 in MADLCS. We are focusing on computational thinking and collaboration, computing in society throughout this. These programming languages really assist in the computer science pathway development. So exploring computer science or introductory computer science course, you can use them in AP computer science principles, and that will be really helpful. Finally, again, going back to the assignments for today, we have the exit ticket posted right here. I'm sorry, the exit ticket is posted right here. You have the homework challenges in here. And I'm also going to post some of the code that we looked at today in here. Try to explore some of these challenges. I envision that we may not have enough time to complete the Python tutorials. So I do not have any JavaScript challenges in here, which is great. There is that multicolor spiral program challenge, which I would attempt with the existing programs, or even change it around, change the parameters around to see if you can get that. If you have any questions, you can always email me. And thank you so much. Lots and lots of resources are posted. Do explore a lot more. In here, what I've posted are some, tutorials for Code Academy, JavaScript tutorials. There are Python basic tutorials. But there is also, a really great programming, computer science programming course at MIT, which is online, and they have like millions of views. So do go there, take a look at it for concepts. Next session is session 11, which is programming games and simulations using Scratch and Star Logo Nova. Thank you so much for tuning in, and we hope to see you next time. Thank you again.